Good day, students. Today we want to solve problem that involve calculations on the uniform meter rule. What we need to do is to draw a diagram that analyze the question given. We are given a uniform meter rule that balances at the 55 centimeter mark. Assume this is a uniform meter rule that balances at the 55 centimeter mark. When a mass of 40 grams is hung from the 95 centimeter mark. Let's do the 95 centimeter mark is hung at that point. That's the mass 40 grams. Is hung from 95 centimeter mark. Find the weight of the ruler. Please take notes when you are told that a uniform meter rule in a question is telling us that the weight balances at the point where center of gravity acts, and it acts at the 50 centimeter mark under uniform meter rule. Let's now see from here to here the balances, the weight of the meter rule acts at the center of gravity. That's the weight W. That it acts at the 50 centimeter mark. Is that okay? When you hear a uniform meter rule balances on a knife edge at that point, always know that the weight of the ruler acts at the 50 centimeter mark, so that you'll be able to subtract it from this point. You have 5 centimeter mark. 55 minus 50 will give you that. Here we have 95 minus 55. You have 40 centimeter mark. Since we are referring to weight, we are going to convert the mass in gram to Newton, because the unit of weight is in Newton. Don't forget that weight equals to mass times acceleration due to gravity. But you have your mass in gram. We need to convert it to the mass to kilogram before we now multiply with acceleration due to gravity g. Now let's now convert 1000 gram make 1 kilogram. That is the standard. You must know that. Now 40 gram to x, you cross multiply. You now have x 1000 times x equals to 40 times 1 divided by 1000 divided by 1000. Just cancel this. X equals 40 divided by 1000. 0 cancels 0. You have 0 points. If you don't know how to do it, go to one side, put 4 here. 1000, sorry, 100. 100 goes in 4, that's 0 point, add the 0. 100 goes in 40, 0, and the 0. 100 goes in 400, that's 4. Now 0.04 kilogram. That's your mass. Mass equals to that. You can see therefore the mass in kilogram is 0.04 kilogram. Now go back to your weight. Your weight equals, what's our mass? 0.04 times 10, because acceleration due to gravity is 10 meter per second squared. Weight now equals 4. Decimal is standing for 1. You shift twice, add 2 is zeros, times 10. 0 cancels 0. You have your weight to be 4/10. 10. 10 goes in 4, 0 point, add 0. 10 goes in 44. That's 0.4 Newton. This is standing as 0.4 Newton to replace the 40 gram. Now, in this case, you follow the moment of force, the condition of equilibrium that says clockwise moment equals to anti-clockwise moment of force. Clockwise moment of force equals to anti-clockwise moment of force. That is the under moment of force. You have to understand the condition of equilibrium. The first one deal with the forces, upward forces equals to downward forces, and the second one deal with the sum of the clockwise moment of forces equals to the sum of the anti-clockwise moment of forces, in which you are going to apply the moment of forces in this case. Now we now have, let's look for the clockwise moments of the force here. This is a clockwise moment of force, and because it's moving towards the right, this is anti-clockwise moment of the force moving toward the left. Now tell us the condition. Said clockwise moment of the force equals to anti-clockwise moment of the force. Let's see the clockwise. 0.4, which is the force, multiplied by the distance, perpendicular distance, which is 40 centimeter. Let's convert it to standard unit. 40 over 100. How do you get that? You have 100 centimeter make 1 meter. Now you have 40 centimeter to what? To x. You cross multiply. You have your x. You have 100x equals 40 times 1 divided by 100 divided by 100. 100 cancel 100. X equals to 40 over 100. That's what you have there. 40 over 100. You convert it to meters. In this case now in meters. Okay. Equals to anti-clockwise moment. The weight W multiplied by 5 over 100. Follow the same way I did this. Okay. Now you have 0 cancel 0. 2 here, 2 here, 5. 5 here, 1. 5 in 10, 2. Bring the 0 here. You have 0.4. You have 0.4 times 2 over 5 equals W times 1, W over 20. Okay. We cross multiply. You have 5W equals, cross multiply like this. 5 times W, that's 5W. 0.4 times 2 times 20. Divide both sides by 5. 5 cancel 5. 5 here 1. 5 here 4. W, which is the weight, equals to 0.4 times 2 times 4. Equal to 0.4 times 8, which is 3.2. 3.2. Let's do the multiplication. 0.4 times 8. 8 times 4, 32. Times 0, that's 3. That's 3.2 Newton. That's the weight. Find the weight of the ruler. If you have to get the mass in kilogram, in this case, you just, if you are asked to get it in kilogram, this is your weight. Don't forget that you have weight to be equals to mg. Now your mass, if you what, divide both sides by g, g cancel g, your mass equals W weight over acceleration due to gravity. That's mass equals, what's our weight? 3.2 divided by 10, which is 0.32 kilogram. But we only have to look for the weight. You stop there. The weight is 3.2 Newton. This is the end of our class. Please subscribe to my channel so that I can have access to the latest video. Have a wonderful day.